So um, the ALCF, the cluster at ALCF has two CS2s. Each chip is, as we saw earlier, very large. I think there was a picture of it as well. It's if you do the arithmetic, it's most of a square part of a 12-inch wafer. There's one management node, that's what applications communicate with and what the utilities communicate with, and a bunch of worker nodes which do IO and compiles, and then a MemoryX and SwarmX infrastructure which handles weights and weight streaming mode. There's also 3 user login nodes. You saw a diagram earlier. The 3 login nodes are slightly separate. They're firewalled off from the CS2 system itself, which can only access the management node. They have broader access to the internet and to other resources at ALCF. So if you have a ALCF account, and many of the people on the call do, good. If you don't, you need to request one using the URL at the right. And once you have and request an account in the left-hand menu, once you have an account, then you want to log in. The menu on the left will change once you log in. Once you log in, you'll want to join the CS2 training project. And after you do that, you want to confirm that it took by looking at whether you have access to the Cerebras system and with the request and view systems pull down. So once you have access, then it's a simple SSH into the system. You're SSHing to one of the 3 login nodes, either using the round robin login or a specific one of the 3 specific login host names. And you're SSHing with your user ID at the host name, and the password is the mobile passcode. And there's no multi-step login. You're in once you've done that. There's that example, and also down at the bottom right, there's how to log into a specific node. Unless you have very persistent SSH sessions, you're going to probably want to persist terminals somehow. We suggest using Screen or tmux to persist terminals across long SSH disconnections. And those are live links to the online man pages for Screen and tmux. However, there are tutorials for those. You might want to look at them. They have idiosyncrasies having to do with things like hotkeys and behavior of tab and various other little idiosyncrasies that you might want to read about. The environment, the Python environment must be set up on a per user basis. Users must create their own PyTorch or TensorFlow virtual environment. At least in our environment, we haven't been able to share Python virtual environments. That's okay, because users are going to be customizing their environments anyway. See the link there for details about how to do it. This is an example for PyTorch and Cerebras release 1.8. You deactivate any existing virtual environments, you make a virtual environment, you activate it, and then you install a wheel file. The install of the wheel file is a few minutes, but it's a one-time thing until the next release. Once you're logging in again to additional SSH sessions or a new SSH session, you need to activate before you do any work. The workflow, the basic workflow is a simple run command. I mean, we saw details earlier about how to separate out things like compile, but Generally, you just run, and the compile is done automatically if there's no cached compile found for the model. And the compile is basically mapping the resources for the application to a CS2 wafer. As you saw, the CS2 wafer is very big, so that's a computationally complex problem. And the compile times can be large for very large models, like an hour or two. Once the compile is done, or if a cache compile is found, the run happens, and you could specify the number of CS2s. In our case, 1 or 2, and at least in weight streaming mode, and you can support, and the support nodes are automatically allocated. They're basically invisible to you. So the model zoo brought that up in the presentation. Here's how I suggest for this particular example how to clone it and get a particular release tag. You can see that the current model zoo for the release 1.8 is dominated by natural language models. The model zoo is updated over time, and so you can expect this list to change and new things to appear. There are TensorFlow samples that are similar, minus the UNet sample. So here's a simple example that runs with the convolutional network that's learning the MNIST, the old MNIST character recognition data set. It's a small model and a small data set, but it's often useful to get this working. So that's the path. And you'll want to make sure that you have a Python virtual environment for Cerebras activated. And this is how I've been running it. If you copy paste these commands one by one, it'll work for you. I can tell you that. The copy command here is because for some reason at ANL that the data set paths in the configuration YAMLs need to be absolute paths. We don't know why, but the modified configuration YAML just has absolute paths to a data set. And then the run command, this simple model is running in what's called pipeline mode, which is sort of a legacy mode. It's running on CS2. We're specifying a label so that other people have some idea what model is running, and maybe if you're running multiple things, you have an idea what model is running. Let's see, the mount directories are because there's containers in the back end, and this is telling to mount particular shared NFS directories. And then there's a path to the model zoo because these samples use common code in the model zoo, and the sample runs in a few minutes and outputs to both the console and to a log file. The GPT-2J sample is a larger model. It's using 2 CS2s in the command line that's shown, and it's running in weight streaming mode. Same drill. You change to the GPT-2J sample for PyTorch. You have to make sure you have a working activated virtual environment, and then you run. Again, it requires a modified configuration YAML. In this case, the modifications are to make the data set paths absolute and to reduce the step count. And when you run, you're specifying that it's CS2, you're specifying that it's in weight streaming mode. It's giving it a label. Otherwise, all of the samples are largely the same as the previous. This sample takes longer to run, and by default, if you copy paste, it'll try and use 2 CS2s. You may end up being queued if you specify 2. You might want to, if you're going to try running the samples, change that to 1. It'll the scaling down to fewer CS2s works just as well as scaling up. So there's that. Utility commands are basically one, CSCTL. That's a link to the online Cerebras documentation for that tool. The verbs are the ones listed. That's from the help screen. The verbs that are commonly used are the get jobs in particular, and the cancel job in particular. I've shown the get where I'm filtering out all of the jobs in a final state because there's a large number of them because of all the testing that we're running. And the watch command basically just repeats that every few seconds. So paths and URLs. There's another link to the model zoo. The systems have a shared directory of common data sets and data sets for some of the samples at that location. And that tree has room enough to put your data sets in if you ask for access or to have a data set put there. There's like 45 terabytes free at the moment. It's an ALCF system, so you have software and projects as common directories. The ALCF user guide is at that link. And I've linked to the Cerebras section in the ALCF AI Testbed user guide. And Cerebras online documentation, I've linked to the wafer scale cluster, branch of the documentation, but you absolutely want to look at the documentation. It's improving rapidly over time, and you will almost certainly find it useful. Allocations, if you're going to be using this CS2 system for more than a week or so, you want to get a director's discretionary allocation, and that's a hot link to the allocation request form.